name is Octavianti. My undergraduate degree was from physics science from ITS, and I had work experience from several companies, different companies, and then I become a lecturer. Started from 2011. So I graduated in 2001. So have you born? No?
No.
Not yet. Okay. I have two kids. Welcome, Ahmed. We're just about to start the class. So please sit down, take a seat. Maybe. Okay. Yeah, you can introduce yourself first. Take a seat.
First, I'm sorry to be late. My name is Ahmed Abdurrahman Yusufi. I'm from Yemen. I live in the Asrama International Degree.
What else? Maybe you can tell about your motivation to join this class, International Undergraduate Program in UB.
Yeah, actually, I entered this class because it's like a scholarship. Yeah, I get scholarship from the university, and I use like industrial engineering because like it's depend on like the material like mathematics, physics. That should be like understanding the keywords like.
Okay, where did you get the information about the UB?
Actually, I have like here students from Yemen.
From your friend?
Yeah, friend from Yemen.
Okay. What do you think about Malang?
So cool.
So good?
Yeah.
Okay, nice. Okay, we can start our class. The first course about the thermometry. Yeah. Okay, before I start the explanation about the thermometry, would you explain what do you think about thermometry? Do you know about thermometry before? Maybe in senior high school, you already learned about the thermometry. Okay, Nico, can you explain? The keyword thermometry. Ahmed.
Maybe talk about the heat or the transformation about the heat.
Yeah, next we will learn about the heat transfer, but this one is, consists of two words, temperature and metry. Nico, your turn. Back to you. What do you think?
Maybe how to calculate heat.
Okay, calculate temperature. Pardon me, your name?
Rio.
Rio. Sorry, it's difficult for me to remember. So I will ask you maybe more than once for your name. Rio, Nico, Ahmed, and Hakam. Okay, so that's correct. Yeah, we will learn about thermometry, the measurement. Metry is measurement of temperature. Yeah, so the temperature itself is the quantity of kinetic energy held by particles in the measure by temperature. Yeah, we usually measure the temperature by touch something. Yeah, that's the subjective way to know the heat or coldness of the object. Yeah, like this. Don't touch, it's hot. Yeah, but the term thermometry literally means temperature measurements and calculations based on temperature conversion through one scale to another scale. That's thermometry. I will share the presentations file through Brown. Do you know Brown? Yeah. Any other lecturer use Brown?
Pak Angga.
Pak Angga. Only Pak Angga.
Yes.
Okay. This semester already give you the code of the Brown? Not yet. Yeah, because we have been waiting for the code from the staff in recording. But I will share later. Okay, as soon as possible. So next, definition of temperature. Temperature is physical quantity that quantitatively expresses the attribute of hotness, how hot, how cold, hotness or coldness of the object we measure. That's temperature. So the temperature is measured with the thermometer. Yeah, it reflects the average. Actually, it's the energy, kinetic energy inside the object, the particle in object that vibrating or colliding atoms while it's we warm it up or maybe in the environment with the cold environment. So it's different. The atomic kinetic energy will change. Okay. So this one, the particle inside the object will vibrating while the temperature of the environment changes. Yeah. This is the definition of temperature, the degree of hotness or coldness of the body or environment. And then another definition is measure of the warmth or coldness of an object or substance with reference to some standard value. So we use a thermometer as the standard value to measure how cold or how hot. Another, this is from the quantum physics point of view, the measure of the average kinetic energy of the particles in a sample of matter and expressed in terms of unit of degrees on standard scale. So it's compared with the standard scale. And next, a measure of ability of substance or more generally of any physical system. Any physical system to transfer heat energy. So it's related with what you said, heat. Yeah, about heat. Thermometry.
Yeah.
No.
Information.
Yeah. So the last, the definition of temperature is any of various standardized numerical measure of this ability, such as Kelvin. This is a different scale of how to measure the temperature. Any question? So today this is the definition, and next we will discuss about types of thermometer. But before, we should know the working principle, how the thermometer measure temperature. Yeah. Okay. Temperature is what the thermometers read. How do we measure temperature? Yeah. Temperature is a measure of energy or heat. There are several ways to determine the temperature. This I said before. One way is by using your senses. You just touch the object and know it's hot or it's cold, colder or hotter. Yeah. Things with less energy will be cool. So the energy inside the particle or object is less than the hot one. Okay. And how to measure the temperature is related with Zero's law of thermodynamics. Could you explain the Zero law? There are 3 laws, right, of the thermodynamics from Physics 1, I think, the last course. Explain. Fundamental Fundamental Physics 1, we learned about the law of thermodynamics. Kakak, would you explain about the... Yeah, it's already explained here, actually, by your own explanation. How the zeroth law stated about the temperature. The keyword is no. Hey, really? The syllabus, it should be explaining the physics.
Heat transfer.
No, heat transfer. Actually, heat transfer is for second fundamental physics 2. For the thermodynamic is for the last course in the fundamental physics 1. It should be explained about this.
Yes, it should.
Who was the lecturer?
Jeffrey.
Jeffrey for the second session.
Yes.
Oh, I see. Yeah, because the curriculum already changed. Maybe for 4 semester already. Yeah, it used to be for the second fundamental physics, but when we changed the curriculum, the law of thermodynamics changed, switched to the fundamental physics 1. Okay, the keyword for the zeroth law of thermodynamics is thermal, how we pronounce equilibrium.
Equilibrium.
Equilibrium. This one. This is the keyword. So when we measure our body temperature, so we wait for a while, right? Not just take a put and then put it. No, we wait until the thermal equilibrium is reached. That's the way we read the temperature. Yeah. So if two systems are each in thermal equilibrium with the third system, so they are in the thermal equilibrium with each. So TA equal to TB, and TB is temperature for C is equal to TB. So T temperature in A equal to TC. Yeah. Next explanation. The visual is like this. So you can see that the system in A and system in B, yeah, with the same temperature. When they reach the thermal equilibrium, so the temperature is similar. Okay, clear? This one, thermal equilibrium. So we can see the first temperature is 100 degree, and when the second temperature is 0, when they touch each other, maybe touch, and then reach the thermal equilibrium, so the temperature is same, becomes same. Yeah. If there is no net flow of thermal energy between them, they are connected by a path permeable to heat. Okay? So next, temperature as the measure of kinetic energy. Yeah. At the particle level, there are atoms and molecules that are vibrating, rotating, or maybe moving through the space of its container. And then when we stick a thermometer in the cup of coffee or tea, yeah, you will see the evidence that the water possesses kinetic energy. Just put the thermometer in the cup of tea. You can see the change. Yeah. Okay. You can read this one. When the temperature of an object increases, the particles that compose the object begin to move faster. The move of the particle inside the object will be faster when the temperature is increased. So the the kinetic energy is related with the movement. So the movement, the more movement, so the higher kinetic energy, right? So, okay, this one is velocity.
Yes.
Velocity, how fast a particle move. Yeah. So faster the particle inside the object moves, so the energy will be higher. Okay. What time? Hey, sorry for late reply because maybe I was driving. Okay. Any question before we go to the types of thermometer? No? No question? You can ask me in Bahasa also, it's okay. Maybe after that you can explain to Matt. Ahmed, how good your Bahasa, your Indonesia language? But at least I can discussion about types of thermometer. This is the history. How our, nenek moyang Pak, ancestors, yeah. 3rd century, before century, Philo of Byzantium. He documented his experiment with a tube submerged in with this kind of container of the liquid on one end, liquid where the liquid I don't know, connected to an airtight hollow sphere on the other, and when air in sphere, this one, yeah, is heated with a candle or by sun, so the sphere will generate bubbles. Yeah, bubbles, and then will pass through the what is it? The tube. Expanding air exits the sphere and generates bubble in the vessel, and when it's cool, a partial vacuum is created, sucking liquid up into the tube. This is the, yeah, they just want to know it's cold or it's hot. There is no scale, yeah. We cannot read the temperature yet, yeah, with this device. Then, on 50-degree thermometers from the mid-17th century, Museo Galileo, with black dot representing the degree. So if it's increased, the liquid in this, what is it? Single degrees, white represented 10-degree increments. Yeah, just see the increment of the temperature, but no scale. Okay, and then, oh, sorry, I will bring my thermometer. Kind of validation thermometer. Average. When we measure the average of the top 20, can see 26 and what degrees below? Ichiban. Sometimes I mix Japanese and English. It's difficult for me because my children always speak in Japanese.
18.
Okay, 18 average from 26 and 18 plus 26 divided by 2, 22. Okay, colder than 23 because the accuracy of this thermometer is not good. So now the thermometer is just for decoration only. But yeah, I put this thermometer in my room. I can see. Good, beautiful, right? Actually, it's okay. There's a lamp here, but battery is finished. Yeah. I bought in Japan. Yeah, we can buy online, but it's expensive here. But in Japan, I only yeah, cheap. But here maybe 500,000 rupees. This thermometer just like this, but it's beautiful, right? Yeah. So, what is the working principle? Back to the principle of this thermometer. There is the density, floating, sink. What kind of low? Low. Do you remember? The low about floating, sink, and yeah. Do you remember? Who's low? Fundamental Physics 1. Right? Fundamental Physics 1, I think. What law? Whose law? About floating. When the object have the density higher than whose law? When the object have the lower density, so we can float, swimming. Huh? Who? Bernoulli, a little bit different. Bernoulli is related with the surface area and velocity, right? That's Bernoulli. But this one, density, rho. Remember? Rho. Who had the experiments about the gold, how to make sure the purity of gold? Not remember.
The case where the
Archimedes. Archimedes law. Could you explain about the Archimedes law?
the case where he have to find the purity of
of
the crown.
crown, and then
He have to
what kind of experiment he did?
comparing the density.
Density. The crown is
Put
Uh-huh.
on the water,
yeah.
different density there.
So not balanced
Not
means
balanced.
that there is the impurity in the crown, right?
It's fake.
Okay. So this thermometer uses the principle of Archimedes. So the bubbles have the with the metal packed in here, so they will have the different density. And the water in this glass tube will influence by the environment, the temperature. So the density will change. The density of this liquid in the glass tube. So when it's hotter, the density will decrease. So it will floating, right? You can see this is the explanation. Maybe you can understand from the explanation. Attached to each bubble is a little metal tag that indicates a temperature. A number and degree symbol are engraved in the tag. These metal tags are actually calibrated counterweights, and the weights of each tag is slightly different from the other. So the density is different. Density is mass per volume, right? So the mass different, so the density will be different. The weight of each tag is okay. Since the bubbles are all hand-blown glass, they aren't exactly the same size and shape. So the bubbles are calibrated by adding a certain amount of fluid to them so that they have the exact same density. After the weighted tags are attached to the bubbles, each differs very slightly in density. So that's why some bubbles will floating and other will sink. Yeah, for this case, you can see the temperature will be 20 like before. Yeah, this 24. Yeah, but when the condition is like this, the same bubbles, yeah, the same bubbles floating, 3 bubbles floating and 3 bubbles sink. So we can read the temperature by measure the average of the top and the bottom. But this condition like this, right? Like this, 2 and 3. But this is odd. Yeah. Bukan 6 ya. Okay. This one means that the temperature of this room is 24 around. This is average. Like this. So that's Galileo thermometer. Next is glass thermometer. We usually use at home, yeah, to measure the body temperature. So the concept of this glass thermometer is, by this liquid in here. Some thermometer using alcohol, another using mercury, the red one. So while the thermometer exposed by the hot temperature, it will, it will expand. Yeah, thermal expansion. Yeah, reach some scale that will, show the temperature of body after the thermal equilibrium is reached. Okay, this is how the thermometer works. This is a part of the glass thermometer. There is bulb here, and this one is the contraction chamber, and this main scale and expansion chamber, the limit. Next is thermocouple. I have this one. I don't have any glass thermometer anymore in my home because break so many times, and it's dangerous, I think, because there is mercury inside the bulb. So I changed with this thermocouple. So if my son have a fever, I just inhale like this, and then I can get the temperature of his body. Yeah, you can thermometer, yeah, in laboratories or in industry. Electrical resistance. The working principle is used in the device to generate voltage that varies according to the connection temperature. Yeah, this one output voltage, and this one is measuring junction. If there's, the heat means that there is or are electrons move, and where the electrons move, so it will generate electricity. If there is the different energy potential, so it will read by the voltmeter and convert to the temperature. This voltage meter. Oh, hi. This one. Junction. Measure junction, and then the metal with different conductivity. Yeah, it's still normal. This working principle. The metal with different conductivity will generate the different potential energy. So this kind of measurement will show the temperature of the object. This is the working principle of the thermocouple. Okay, any question? Okay, we go to the next type of thermometer called platinum resistance thermometer. A platinum resistance thermometer, or PRT, is a piece of platinum wire which determines the temperature by measuring its electrical resistance. A similar principle with the thermocouple, but the thermocouple used to measure the voltage, but this thermometer measure the resistance. Yeah. Okay, any question? I think it's the range of the standard platinum resistance thermometer is around minus. It can measure the cold temperature from minus 196 until 962. So very long interval. Okay. Yeah, this kind of thermometer we can find in our laboratory, SISMAN, system manufacture laboratory. This is infrared thermometer. So the working principle is using the infrared. Infers temperature from a portion of thermal radiation from the object. It will, sometimes called black body radiation, emitted by the object. We know that any object will emit the radiation from its particle, and by knowing the amount of infrared energy from the object, we can measure the temperature. Okay, this device known as thermal radiation thermometer. Why infrared? Because its accuracy higher than another thermometer, and for safety, because we can measure the temperature of object from the distance, long distance. So, and another is contamination prevention. When COVID pandemic, there are many clinic used infrared. Do not touch the patient, and then just using this shoot with the infrared thermometer. Another kind of thermometer is medical thermometer. For medical thermometer itself, there are types of thermometer, ear thermometer, and then just like this. But the concept is same. Zeroth's law of thermodynamics. Okay, for this discussion, find another type of thermometer and explain it. You can Google or maybe searching